Okay, so last section of the solutions chapters is the concentration of solutions. Like I said, looking at the quantitative aspects of making a solution. And so there's two ways that we can actually make a solution, starting with a solid solute. This should be like what's pictured here, dissolving some ammonium dichromate in water, and then diluting a liquid that already exists or a solution that already exists. So you are going to need to know this procedure, not just how to do it mathematically, but be able to describe in 2 or 3 sentences how you would actually do this. And being specific enough with the actual names of the equipment. Okay, it shows up every year on the AP test somewhere. So the first thing that you would do is you would weigh out. That's what A is. It would be mass out or weigh out. The appropriate number of grams of solid solute. Then what you would do is you would add it to this particular piece of glassware, a volumetric flask. You must say the word volumetric flask. It is not a beaker. It's not a graduated cylinder. It's a volumetric flask. It's not an Erlenmeyer flask. It's a volumetric flask. A volumetric flask is a piece of glassware that reads actually only one volume, but it reads that volume extremely accurately, right? Remember accuracy, getting close to the actual answer. So it's actually not even printed on the glassware. It's ground in, so it can never rub off exactly where 250 milliliters is. And then what you would do is you would take water. It doesn't need to be from a graduated cylinder, but you would take water and you would say you would add the H2O till you reach the mark. You wouldn't not say you add 250 milliliters of water because in fact, you often do not add 250 milliliters of water because the actual solid that you have, those are atoms. They take up volume, they have mass, and they take up space. And so you will probably wind up adding a little bit less than. So that's why you would say you would fill the volumetric flask to the mark and then invert several times in order to dissolve. This goes back to the unit that we are going to use to measure the concentration of a solution. And the unit that we're going to use is something called molarity. There's many other different ways to describe the concentration of a solution, but molarity is by far the most useful one in chemistry. There's different ones if you're in biology, percent solutions, percent by mass, percent by volume, there's molality, there's a whole bunch, but we in chemistry use molarity. Molarity is moles of solute, over liters of solution, not solvent. Right? That's why we needed to not add 250 milliliters, but add the water till you reach the 250 milliliter mark, because that would mean I have 250 milliliters of solution. The symbol for molarity is a capital M, right? It's really important because we know lowercase m is mass or meters, depending if it's used as a unit or a symbol. Moles we know is MOL and liters capital L. So let's start doing some of these math problems here. So the first one, a 100.5 milliliter IV solution contains 5.10 grams of glucose. What is the molarity of the solution? And then you've given the molar masses of glucose. So anytime that you are given, right, circle the do, underline the clue, questions asking me for molarity. Molarity, right, with formula, plug the numbers in and solve. Molarity equals moles per liter. Read the question again. What are the clues? 100.5 milliliter solution, right? It tells you it's the solution. So first thing I'm going to need to do is, and you can do this in any different order, but that 100.5 milliliters must be in liters, right? We remember 1,000 milliliters is equal to 1 liter. Divide by 1,000, I get 0.1005 liters, must be in liters. So that's my denominator, 0.1005. And then the second part here says that it contains 5.10 grams of glucose, and here's the molar mass of glucose, right? I need to put in moles, so I need to convert my grams to moles. 5.10 grams of glucose, convert to moles. 1 mole is equal to 180.16 grams. Okay, divide those two, and I get 0.02830 moles. That's my numerator, 0.02830 moles, right? Remember, not really worrying about significant figures here to the end. So in my calculator, I'm going to use these numbers completely unrounded. Divide those two numbers, and I get 0.28167. And now go back and look at significant figures, right? The volume had 4. When I converted it over to liters, it still had 4. This number had 3, and so my answer should just have 3. So I'm going to round this to 0.282, right? And then what are the units? I could write moles per liters, but most often what we write is 0.282 with a capital M after it, meaning molarity. So we would say the vocabulary that we would use is this is a 0.282 molar solution. And that tells me how concentrated it is. If I had less glucose in there, it would be less concentrated. If I had more glucose in there, it would be more concentrated. All of these problems are just variations on that same idea. How many moles of ammonium nitrate are in 355 milliliters of 0.425 molar ammonium nitrate, right? Formula. Molarity equals moles per liter. I know my molarity, that's 0.425. I don't know the number of moles, and I can't put 335 milliliters. I need to convert that to liters, right? And so that equals 0.335 liters. Right? Algebraically, what do I do to solve for a mole? I multiply those two numbers together. When I multiply those two numbers together, and again, my answer is going to have 3 significant figures. I'm going to get 0.142, and right? And that should be the number of moles. Think about this capital M is just another way of writing moles per liter. And then I multiplied it by liters, so my liters units cancel. Okay? Moles of, what was it? Ammonium nitrate. Question 3. 250 milliliters of 2 molar KBr is needed. How many grams of KBr must be massed out? So 250 milliliters, that's my volume. This is my molarity. The question is asking for grams of KBr. So my formula, molarity equals moles per liter. My number, or my molarity, is 2.00. I don't know my number of moles. I know that my volume is, you don't have to write this out every time, unless you get it wrong. So, if you are getting this correct every time, you can do it in your head, that's fine. But, this would be a horrible way to get a problem wrong on the AP Chem test because you converted from liters to milliliters or milliliters to liters incorrectly. Now, when I multiply those two numbers together, I'm going to get 0.500, and that's the moles of KBr. But the question didn't ask for moles of KBr, it asked for grams of KBr. So I'm going to need to convert from moles to grams. The molar mass of KBr, adding up 1 potassium and 1 bromine, is 119.0. Right? Multiply those guys together, and I get 59.5 grams of KBr. Right? 3 significant figures there. Every number that I use in this problem. It has 3 significant figures. Molar masses, remember, they do count, but they always have 4. Metric conversions, they don't count, so that doesn't matter. Okay, so that is if we're starting from a solid solute. But sometimes we do what's called making a dilution. And when you make a dilution, you actually use a more concentrated solution. You're still always going to use a volumetric flask. So what you would do is you would remove the desired amount of the concentrated solution. So sometimes that's called the stock solution. It's always more concentrated. Sometimes we call it a stock solution because that would be like how it comes from the chemical company. So for example, when we order hydrochloric acid, we get 12.0 molar. That's the most concentrated hydrochloric acid that you can get. And then if I need 1 molar for a lab, I will dilute it, right? So you use or you somehow need to get a very specific amount of the stock solution. The example here is using what's called a volumetric pipet to remove a specific amount. Sometimes you will also see the wording that you should use a burette to remove or to dispose of a very specific amount of the concentrated solute. Then what you would do is you would add that volume of the stock solution to another volumetric flask. And then again, we would add water till we reach the mark. So I would never say you add 35 milliliters of water, right? Volumes are not always additive. So let's say that this was, let's say 50 milliliters. And so you would assume if you're going to, let's say this is a 250 milliliter, you would say, well, I'm probably going to add 200 milliliters of solvent, of water, if that's the solvent. Well, that's not always true. 50 milliliters of one liquid plus 200 milliliters of another liquid doesn't always equal 250 milliliters. Volumes aren't always additive, especially if they have really strong intermolecular forces. It can be oftentimes less. So we wouldn't say add 200 milliliters. We would say add water till the 250 milliliter volume mark was reached. And the formula that we use for this is the dilution formula, M1V1 equals M2V2. The new molarity, or I should say the original molarity times the original volume equals new molarity times new volume. Remember, molarity is moles per liter, and volume, if that's in liters, those cancel. And if we're looking at this case, right, the number of moles in this guy right here, right, this number of moles is actually the same as the number of moles in this diluted solution, because all I'm doing is I'm adding water. The number of moles stays the same. It's just the volume that changes because I'm increasing the volume of the solution by adding solvent. So question number 4, what volume in milliliters of 2 molar calcium chloride stock solution would you use to make a half liter of 0.3 molar calcium chloride solution? So formula M1V1 equals M2V2. So the question is asking what volume of the stock solution. So 2.00 molarity is the molarity that I know, but I don't know the volume of that. I know that I'm going to dilute it so that I make a new molarity of 0.300, and my new volume is 0.50 liters. Okay, multiply those two, then divide by 2.00, right? Units cancel. So my new volume, or the volume of the concentrated solution, would wind up being 0.075 liters. Check your, we always say check your work. Look at what this problem says. What volume in milliliters? So I now need to convert this back to milliliters. And that would be 75. So 2 significant figures here. 75 milliliters that's this, right here. That's what I'm going to remove, right? I'm going to remove 75 milliliters. I'm going to add it to a new volumetric flask, and I'm going to add water till I reach the 0.50 liter mark. Number 5, how could you prepare 250 milliliters of 0.2 molar NaCl using only a solution of 1 molar NaCl in water? So this is, the question's asking, how could you prepare? It's asking you for the number of, like, writing out words to describe how you would do this. But the first thing I need to do is some calculations. I need to actually figure out what numbers I'm going to use. So I do the dilution formula. My original, or what do I need? So this is the 2 that I know something about. And it doesn't matter whether you use 1 and 2. They just need to always match up. So let's see, 0.20 molarity. And I'm going to prepare 250 milliliters of this. It's okay that I didn't convert this to liters, and I'll show you why in a second. Using only a solution of 1.0 molarity. Right? So if I divide both of these by 1.0 molarity, that's pretty easy, right? Notice the units. These molarity units cancel out. And so my answer is going to be 50. The unit is still going to be milliliters. 2 significant figures here, so 50.0 milliliters. So that's the volume of the concentrated solution. So now the question is asking me to actually write it out a little bit. So the first thing that I would say is use a burette or volumetric pipette to measure out 50 decimal point milliliters of 1.0 molar NaCl. You could, if they do not give you a list of, or if they do give you a list of equipment, you could use a graduated cylinder, but a graduated cylinder is not as accurate as a burette or a volumetric pipette. Okay, so I wouldn't use graduated cylinder unless they didn't give you a choice. The second step would be to add the 50.0 milliliters. I guess it's not 50.0, it's 50 milliliters of NaCl solution to a 250, that's my final volume, milliliter volumetric flask. And then the third one is add, I love how it thinks I want. Nope, thank you. The third step would be to add water to reach the mark on the 250 milliliter volumetric flask. Right, and so those would be, this is a very common AP chemistry question, would be actually asking you the steps of how to do this. I just added to this the 2 more formulas for percent solutions. If you are, these are used often, much more often in biology than they are in chemistry, but it would say percent by volume. So you might say, I want a 5% by volume solution of something, and it would be the volume of the solute over the volume of the solution. Percent by mass would be mass of solute over mass of solution. You're not going to see those in AP chemistry, so you don't really need to worry about them. And that's it for solutions. So try those homework problems. I'll put the answers to the homework packet. Will be, I don't know where I'll put that. Shoot, I don't know, I'll put it somewhere or I'll email it out and check those work. But what is due for solutions is, for Unit 8, is really your completed notes packet. So that needs to be filled out, scanned, and emailed to me. Okay, any questions, just email me over the summer.